Hello everyone, and welcome to day 3 being the chain rule. So if we recap, the first 2 days we did power rule, constant rule, product rule, quotient rule, and then we added trig functions in. Today is a whole different concept. We're looking at more complex functions and taking the derivative of those more complex functions. Chain rule. With the chain rule, we need to look at functions being compositions. Remember that compositions are something that you have two different functions and kind of one's inside of the other, if you want to think of it that way. And so we need to break it down. That's step 1. Find the derivatives of both of those functions. And then you're basically going to multiply and substitute back in. So how we want to look at this first one, and I've done the first 3 for you out. That should help you see it, and then we have some ones to do on the own. I'm not going to go through all of them just because of time's sake, but please pause the video and look at them as we go through it, as you go through them. So the first one, see how you have a square root and something is inside of it. So our main function, our outside function, is what f of u is, and u is the inside. Inside versus the outside of it. And so when we look at that, if you plugged u back in, you would get what the original function f of x is, or in this case y. So we have each of them. We take the derivative of each of them. Remember that anything square root is u to the 1/2. And so we have the derivative of each of them. And what you're going to do now is multiply the two derivatives together. Now, taking the derivative of y needs to be with respect to x. If you look here, we have a u. That's unacceptable to have a u. So the last step in number 4 is to substitute u back in. Well, what is u? U is x cubed plus 1. So it was what we did here. We substituted it back in. And notice that the negative brings what is raised to the negative power. So x cubed plus 1. We bring that down to the denominator. This is already in the denominator. And the 1/2 is a square root. So that's how we got the final answer. You cannot cancel anything. There's no canceling here. So if need be, pause it, rethink this, rewind it, whatever need be. We're moving on to the second example. Second example, inside function, right here, inside. Cosine of x is your outside. Outside function, cos f of u is cos of u. U equals x squared. We could just plug back in to get f of x. Take the derivative of each, 2x, and negative sine u. Remember that the derivative of any trig function starting with c is negative. So we got negative sine u. We multiply those two together, and then we substitute back in. This x squared goes in. That's how we got it. I should probably put it over there too there. So we brought the negative and the 2x out in front, and we're left with sine of x squared. Again, the idea is you have two different functions, you break them up, take the derivative, plug in, and then simplify. E to the 3x minus 1. Outside, that's the exponent, the inside is e to the u. So we got 3x minus 1, e to the u. The derivative of e to the u, even though we have not gone over this, is e to the u. So we get e to the u is e to the u. U prime of 3x minus 1 is 3. Multiply these two together, e to the u times 3. Plug what u is back in. Bring the 3 out in front, e to the 3 to e to the 3x minus 1. So again, if you need to, go back, re-look at those. I'm going to move on to doing the next 2 examples. So what is f of u? F of u is u to the 1/2. U is the inside, x cubed plus 9x plus 2. F prime of u is 1/2 u to the negative 1/2, just the power rule. U prime, 3x squared plus 9. So this is step 1, step 2, step 3 to multiply those two together. So 1/2 u to the negative 1/2 multiplied by 3x squared plus 9. Right here, sometimes people think it's easier to simplify first with this portion of it. So I'm going to bring down the u to the 1/2 multiplied by 3x squared plus 9, which we can also say is 3x squared plus 9, all divided by 2u to the 1/2. So the final step, and we can call this f prime of x. I apologize for not using notation here. F prime of x, we plug in what u was, u's here. We plug that in. 3x squared plus 9, all divided by 2, square root of what u was. X cubed plus 9x plus 2. And you're done. Notice I just paused the video. I did put in the correct notation back there just in case you wanted it. But this would be our final answer. Moving on here, f of x is cosine squared x. We need to recognize, and this is going to be important for the rest of the year, is that that can be written as cosine of x quantity squared. So the inside, outside. So f of u is u squared. U is cosine x. Take the derivatives of those, is 2u. Take the derivative of u prime, negative sine x. Multiply those together, is negative sine x times 2u. And the simplifying, we wrote that incorrect, that would be completely wrong. That's a common mistake that we do not want to have. Sine of x multiplied by 2u. If we wanted to simplify that, this is key, it's not sine of 2u. If you wanted to simplify that, we could bring the 2u and negative out in front. And then the final answer, f prime of x, plug in what u is cosine of x, goes in there. So negative 2 cosine of x multiplied by sine x. Done. This one should be recognizable. Outside, inside. I'm going to pause this and do it out so we don't waste time. So bear with me. You should also pause this and do it out and see if you get it correct. So hopefully you did the problem, and if you have not, pause it and do it. Here is the answer. 2 cosine of 2x plus pi over 4. One of the things that I like to show people is that is the long way of doing it. And I do have a shorter way of doing that. So right now I'm going to show you the quote quicker way of doing it. And then hopefully we'll have time to do the last example on page. So I went back to the beginning of the notes to show you the quicker way, and I have it written out here. The saying that I use is derivative of the outside, keep the inside the same, multiplied by the derivative of the inside. I want to show it to you on the example at the bottom of this page, and then we'll keep looking at more examples here. But the derivative of the outside, keeping the inside the same. So if we look here, outside, inside, I'd already written that once. But the derivative of the outside is negative sine, okay? That's the derivative of the outside, multiplied by the inside, or keep the inside the same. then multiplied by the derivative of the outside, 2x. Bring this 2x out in front, you get negative 2x sine of x squared. That's everything we just did, but in a shortcut way. We look at this one. The derivative, take the derivative of the inside, or take the derivative of the outside, e stays e, keeping the inside the same, 3x minus 1, multiplied by the derivative of the outside, or derivative of the inside, excuse me, 3. And you rewrite that as 3 e to the 3x minus 1. So let's look at the next two examples here. The derivative of the outside, so we know it's really x to the 1/2. So the derivative of that is 1/2, and then something to the negative 1/2. Keeping the inside the same, x cubed plus 9x plus 2, multiplied by the derivative of the inside, 3x squared plus 9. And if we redo all that to make it look nice, bring that to the bottom. And then we could just put that over there, getting the same answer as before. The derivative for the next example, let's try to move quick here. The derivative of the outside, 2, for the first, keeping the inside the same, multiplied by the derivative of the inside. So we're left with negative 2 sine x cosine x. This one, again, outside, inside. The derivative of the outside, cosine of, keeping the inside the same, multiplied by the derivative of the inside, 2. Rewrite it. There you go. So a little shortcut way of doing that. I'm going to skip to the bottom one, and then I'll do the last one on paper, just not out for you. So this one's going to be a triple chain rule. Notice that we can do sine of cosine of 4x all squared. We're still looking for the derivative of that. So the derivative equals the derivative of the outside, that's the outside, 2, keep the inside the same, to the first. So, the derivative of the outside, keeping the inside the same. But notice that we have to take the derivative of the inside. So we took the derivative of that, now we have to take the derivative of the inside. Well, that's another chain rule. So we need to take the derivative of that, multiplied by the derivative of its sine, cosine, keeping the inside the same. So we just did that, multiplied by the derivative of the inside. Well, the inside is now here, so now we're taking the derivative of that. The derivative of cosine, negative sine, keeping the inside the same, multiplied by the derivative of the inside again, which is times 4. So if we look at all of this, you have the derivative of the outside, which we did here, kept the inside the same. Then we get to the next portion, derivative of that, kept the inside the same. The derivative of cosine, kept the inside the same. Derivative of the inside, and then we're done. So our final answer here is 8. That's where the 4 and the 2 come from. The negative, so we took care of that. Sine cosine of 4x times cosine of 4x times sine of 4x. Okay.